Hello, Math Humans. We're going to do 5.3 today. We're going to start talking about inverse functions. Our objectives are that we're going to verify that one function is the inverse of another, and then we're going to determine the inverse. So both of those things are things that we learned in pre-calc. And then, shouldn't say definition, then we're going to find the derivative of an inverse, okay? Alrighty, so what I've done is pre-written some of our notes from pre-calc. If you'll remember, there are three different ways that you can find the inverse of a function. The first is that you can exchange your x and y values from a table, and we are actually going to use this method later. So if my function had points 2, 3, 4, 5, 6, notice that for the inverse, the x and the y trade places. So notice the range became the domain. So this is the information that we're going to use later when we start taking the derivative of an inverse. Okay. The second method that you learned in pre-calc was that you can take the original function and reflect it across the line y equals x. And so notice that f to the negative 1 is going to be my inverse. I do want to go back up and talk about this in calculus, and often in pre-calc as well. When we write the notation f negative 1 of x in calculus, oftentimes the inverse is called g. So you just want to make sure that you pay attention to the notation as you work through a problem. The third method is where we flip-flop the variables in an equation. The piece that most of us forget is that we solve for y. So if I have y equals x squared, then I make this x equals y squared. I solve for y, and I get plus or minus x. Okay, so that was your crash course in pre-calc on ways to find inverses. So the beginning of this assignment will have you start finding some inverses. The next thing that I want to talk about is verifying an inverse. And so sometimes what they wanted you to do was verify that f of x and g of x were inverses of each other. And if you'll remember, if I do the composition f of g of x and I get x, and then I do the composition g of f of x and I get x, then I know that those two functions are inverses of each other. Okay? I have some observations about inverse functions, so observations about our inverse functions. Ooh, it's a lot of writing. Alrighty, the first one is if f is the inverse of g, then by default, g is the inverse of f. The second one would be that the domain of the inverse, so f negative 1 of x, is equal to the range of the original function and vice versa. And we actually will use this information as we get ready to solve equations. The third observation is that every inverse is unique. Okay. The fourth one is an inverse exists if and only if f is 1-to-1. And we learned that vocabulary word in pre-calc. And a function is 1-to-1 if it passes, so the function passes both the vertical line test and the horizontal line test. And what that tells you is that both the function and the inverse are functions. Okay? Instead of just a relation, they're both functions. And then a new vocabulary word is strictly monotonic. And that means if a function is strictly monotonic, then f has an inverse. And then let me explain strictly monotonic. Strictly monotonic means that a function is either entirely increasing or it's going to be entirely decreasing. So it means that there's no change in the function from increasing to decreasing. So a strictly monotonic function has an inverse. So now let's do a couple of examples. So example number 1 says verify that f of x and g of x are inverses. Okay, so you're going to be given that f of x is equal to 2x cubed minus 1, and g of x is the cube root of x plus 1 over 2. To be able to verify that the function are inverses, I need to do the composition. So I'm going to do f of g of x. You can also do g of f of x. It doesn't matter which you choose to do. Some of it's just about which math is simpler. I'm going to choose to do the first one. Remember when I do a composition, so I'm going to write f of g, which is the third root of x plus 1 over 2. And now this becomes the input into this function, so then that's going to be 2 times the third root of x plus 1 over 2 to the third power minus 1. Well, if I raise this to the third power, the roots cancel, so I'm going to get 2 times x plus 1 over 2. The 2's cancel, there's the negative 1. X plus 1 minus 1, those cancel, and I get an x. Therefore, f and g are inverses of each other. Okay? Example number 2, we're going to have find the inverse of f of x is equal to the square root of 2x minus 3. So I'm going to do this by flip-flopping my variables. So I'm going to do x is equal to the square root of 2y minus 3. The goal is to solve for y, so I'm going to square both sides of the equation, and I get 2y minus 3 is x squared. 2y equals x squared plus 3, and then y is going to equal 1 half x squared plus 3 halves. The notation is important, so when I report, I would say that the inverse is equal to 1 half x squared plus 3 halves. Even though you solved for y, that y represents the inverse, so you want to make sure that we report our solutions well. Okay? So a couple of other things that we need to notice about our inverses: if f is continuous over its domain, then its inverse is also continuous over the domain. Okay, so if one is continuous, then the other is continuous. The next thing is if f is increasing over its domain, then the inverse, f negative 1, is decreasing over the domain. And if you go back and think about what we talked about at the beginning of the chapter, when we talked about reflecting the function over the line y equals x, then that means that the function is going to go from increasing to decreasing. The next one says if f is decreasing over the domain, then the inverse is increasing over the domain. Okay? And then the last one is if f is differentiable at a constant c, then the inverse, f negative 1 of x, is also differentiable at the same constant. Okay? So if one thing is possible at the function, it's also possible at the inverse. All right. So now we're going to talk about the calculus version of inverses, and we're going to want to calculate the derivative of an inverse. Okay, and this is going to be another formula that you should add to your formula sheet. And so remember that g of x is often going to represent the inverse. So f is equal to the function, and in calculus, g is often equal to the inverse. So you always want to make sure over the course of the problem, but the standard notation would be that this is the inverse. That's going to equal 1 over the derivative of the original function evaluated at the inverse. Okay? So remember, f is the function and g is the inverse. These problems look complicated, but they're really very simple if you remember the format. All right. So we're going to just walk through an example. So this is going to be example number 3, and I'm going to show you how the system works. So we're going to be told that f of x is 1/4 x cubed plus x minus 1, and I want to know what is the value of g prime of x when x equals 3. Okay? So the first thing that I'm going to do, your very first step, is to put f of x into your y. Okay? So I'm going to go in and do that. So if I bring in my handy dandy calculator, oops, mine's in the wrong mode. Let me go back and fix that. Second quit, y equals, and I'm going to delete what's there. So if I put in the equation, I'm going to do 0.25x to the third plus, oops, delete that guy, plus x, and then minus 1. And I'm going to put that into my calculator. And then I'm going to look at the table. So then I'm going to check my table set. I want it to change in ones. And then I'm going to actually go physically look at the table. And if you'll notice, what I'm looking for is I'm looking for the y value that equals 3. Okay, and because of the inverses, so in my table I had f of x equals 3 when x is equal to 2. And let me bring that back just to make sure that you can see it. It's right there. Okay, and so this is that point where we have flip-flopped the ordered pairs. And so now I'm going to write the point 2, 3. So the g is going to be the inverse. So it's going to be, I'm going to write it like this, is equal to 2. And notice all I'm doing is flip-flopping the ordered pairs. So if I want to evaluate the derivative of the inverse when x is equal to 3, my formula is g prime of x is equal to 1 over f prime of g of x. So this is going to be g prime of 3 is going to equal 1 over f prime of g of 3. And this is 1 over, and I'm writing all these steps down just so you understand. So notice I really have not done much work at this point. All I did was put this equation in my calculator, find the y value when y is 3, because it's the opposite, and then I wrote down the x value 2. So when I'm looking at the inverse, when I do g of 3, it's going to be the opposite inverse. So now if you'll notice the notation, I actually need to take the derivative of my function. So f prime of x is going to equal 3/4 x squared plus 1. And then I need to evaluate the derivative at 2. So it's going to be 3 over 4 times 2 squared plus 1. So it's going to be 3 plus 1 is 4. So g prime, scoop my paper up, g prime of 3 is 1 over 4, and we're done. So these problems often are not difficult, but you do need to remember the process. Okay? All right. I have one more example, and then we'll be done for today. So example number 4. We're going to be given that f of x is equal to x squared, but we're only going to consider x is greater than or equal to 0. So if you think about the graph, we're going to do that portion of the parabola. And I know that the inverse of that is going to be equal to the positive root, because I only considered this portion. And the directions say I want to show that the slopes of the graphs of f and f negative 1 of x are reciprocals at the point 2, 4, and then 4, 2. So I'm just going to rewrite my information. So I have f of x is equal to x squared, and I have f prime of x is going to equal 2x, and then I want to do f prime of 2, and when I do that, I get 4. So then I'm going to have the inverse of x, which is square root of x, right? And now I'm actually going to change this variable to a g, so I'm going to let f negative 1 of x equal g. So now I want g prime of x, because remember, if we're talking about slope, we want to evaluate our function. So this is the derivative of the inverse is going to be 1/2 x to the negative 1/2, which is 1 over 2 radical x. So all I did was take the derivative of the inverse, and then I want to evaluate g prime of 2, and when I do that math, I get 1 over 2 times the square root of 2, and I get 1 over 4. So notice that the derivative, the slope of the original function, and the derivative, the slope of the inverse, are reciprocals of each other. So it really wasn't a difficult problem, but it actually turned out pretty nicely, and I wrote this badly as I just check over my work. There we go. I used the wrong point. Should have used that one. Alrighty, that's it for today. I will